can see over here, we have our H bridge over here. You can see this is our power source. This is coming here, and this is the ground of the main power source going to here. And this is our first transistor, that is PNP, second PNP, this is NPN, and this is NPN. Now the PNP transistors are connected to the positive side, and NPN transistors emitter is connected to the negative side of the main supply. While instead of microcontroller, we are going to use these 5-volt sources. Like PNP side only gets triggered when a 0 is sent from the microcontroller. So once I close this pass gets closed, and we get some voltage through this over here. And then when I close this side, then we get the 23 volt, because NPN transistor only conducts when a positive is given to its base pin, or in case of a MOSFET at the gate pin. So we got the positive here, and PNP only conducts when a negative is given. See, there is the negative side and it's conducting. So if we send a 0 from the microcontroller, this will get triggered, and 1 to this, and this will get triggered. So motor will be in one direction, that is positive 23.96 volt. Now you open these two switches. I close this one and this one. Now see, it's negative. So this means the direction of the motor has been reversed. And now to control the speed, you just have to give over here the PWM. Instead of giving 0 or 5, or like 1 or 0, you just give PWM pulses through your microcontroller. Hello guys, welcome to learning microcontrollers. In this video, I will show you what is an H bridge and how it works. So we will get through what an H bridge is and how it works, and I will explain this to you using a simulation on Multisim Live. So guys, first of all, we should know why we need an H bridge. Number one, the main task of an H bridge is to control the direction of a DC motor using a single power source. Like you know that if you want to invert the direction of a DC motor, you need to invert the power terminal, like positive to negative and negative to positive. Now you cannot do this with a single power source, it will get shorted. So H bridge is a technique which allows you to do that without using a multiple power sources. So you only need one power source to control the direction of a DC motor. Number two is to control the speed of a DC motor. So you can also make an H bridge using relays as well. If you make an H bridge using switches or relays, you can control the direction. But you cannot control the speed, because to control the speed, you need to give the PWM frequency to the PWM frequency. And PWM frequency is this much high switching rate that relay cannot endure it. Relays don't have this much speed of triggering. So you need transistors. So if you make an H bridge using a transistor, you can do the both. Now let's go to the simulator and see what I was talking about. So just go to your browser. I have a video lecture on that, how you use, how to introduce to the Multisim Live simulator. So you can go through that lecture if you have any problem. So just go to Google, write on Multisim Live, click on this link. Now on the login window here, write the email which you have registered as shown in my lecture on this. Please go through that if you have problem here. Click on login. Okay, wait, it's logging in. Okay, here we go, create circuit. Okay, now this is our window. First we make an H bridge using relays. Like we want to control the speed and direction. So first we use just switches for relays. I just use these switches, SPST switches. I place one here. Let's rotate it. Copy this. Paste one right next to it. Then copy this. Paste both here. So like this. Now connect this part to here and this to here. Like this. We are making an H bridge, and from above we give the positive and below will be the negative. So like this, you connect these two part, and below you connect these two part. Like this. And in the center we will have motor. Here you will have motor, but on Multisim you don't have a motor of that sort. So we will just use the resistor. Resistor will represent the motor. So you just think of this as a motor. So I name it DC motor. Okay, DC motor. Okay, but just consider this a DC motor. So I connect this end to that side and this end to that side, like this. And then we need a power source, a single power source. This will be the DC voltage, this one. Okay, just I will edit the symbol for easy understanding, this one. Okay, now I make it like 24 volt or something, whatever is preferred. So I make it 24. So our power source is 24 volt. Connect the positive to the upper side like this, and negative goes to the bottom side like this. And guys, this is our H bridge. Now how we know that how it's gonna work? Now see, this is the DC motor. Now to make the DC motor move, if we give positive at this end and negative at this end, it will start moving in one direction. So that is true. Right now our positive is here and both the switches are open, S1 and S3. This means the motor will not get any positive, and from the bottom side we have the negative. Also add a grounding symbol for the simulation purpose, because once we run the simulation it will ask for the ground. So this is only for the simulation purpose, like this. Now if see, these two switches are open now, so we don't have any connection to the ground. So like I want to move the motor in one direction, I will need positive here and negative at this terminal. So let's give it. So I run the simulation has started. Now see, there is no load here. Okay, we also use a voltmeter to see what is we are getting. So I attach a voltmeter positive probe here and a negative probe over here, like this. So right now once I run the simulation, see that 0 volt. Now if I open this switch, see, still some leakage voltage, still we didn't got the 24 volt, our supply is 24 volt. Now once we close this switch, positive coming from here goes here on the left side, it goes through this switch to this terminal of the motor. Now this is the terminal of the motor getting the power, but this terminal we need a negative over here. We don't get negative here. Like from the bottom side, this is a negative side and both the switches are open. Now to get negative here, we need to close this switch. Now see, 24 volt. This means our motor is running with 24 volt in one direction because this and this switch is open. So our path starts from here. This is the positive side. We get positive here from that side and negative here from that side, like this. So if I write it using an annotation, okay, I will write it like this. I write positive and here I got negative. Now see, is it true that this terminal is now positive and this is negative in this configuration? Now again I run the simulation. Now take a look here. In this configuration, this is the positive side and this switch is closed. So this terminal is not getting any power from here. So it is an open circuit here. And at this side, we have closed the switch. So that way the power goes here and this terminal has become positive. Now to make this terminal negative, to make the motor move in one direction, we keep this switch open, because if this switch is open, if we close this will get shorted. So that is the beauty of H bridge. This switch is open. Only if this and this switch is closed, then your motor moves in one direction. Now if I want to invert the direction, I want to make it negative, I open these two switches like this, and now I want the positive to come to this side. Okay, I want the positive to be the other side. I make this negative and I make this side positive. Now I want to do this. Now see, the positive is coming from here. Now this is the positive source, 24 volt, goes there and there. Now if I close this side, see, if I close this switch, the positive comes over here. See, the positive is here now, but still the motor will not work because we didn't give negative to this terminal. Now we want to give negative to this terminal. To give negative, we close this switch. Now see, it is minus 24 volt. This means the motor will be now moving in the opposite direction. So that is how the H bridge works. You only need one power source and 4 switching things. Now the next question is, now see, I open this terminal, motor is stopped. Now close these two terminals, positive 24 volt. Now I open these two, I close these two. Now it's negative 24 volt. This is how you control the direction of a DC motor using the simple, you can say, relays or switches. This is basically an H bridge. Now the next question is, as told you in the presentation, we need to do two things using an H bridge. H bridge does 2 things. So let me write down over here as well. Number 1, main task of H bridge. Number 1, direction of a DC motor. Number 2, speed of a DC motor. Okay, now problem is that we have got the direction to be controlled, but with these switches we cannot control the speed. Now we need something else. Now we use, here comes the transistor into play, because even if we use a relay, is also like a switch. Maximum that PWM frequency the relay can have is like 35 millisecond, while we need it in microseconds or nanoseconds, like in 5 kilohertz or 10 kilohertz to generate the PWM. So the PWM will control the speed. Now what I do is that I make another H bridge. Now what I do is that I go to the left, I bring in transistors. I bring PNP transistor, 2 PNP and 2 NPN. Now I bring a PNP transistor to replace this. I rotate it so I can make it look presentable like this. I copy this, I bring it to this side. I also rotate it like this. Now we are bringing in the transistors. So I delete this, and instead of that I connect a PNP transistor at the position of the first relay, first switch. Now the same H bridge, just we are replacing switches with transistors. So here you go, like this. Now I do for the opposite side as well, this one. So I delete this switch and I bring a transistor at its place instead. So I connect this back like it was over here, like this. Now do the same for the bottom side, just connect it here, like this. Now again, what do I do for the bottom one? Again we need, now for the bottom side we need 2 NPN transistors. Go there, bring in an NPN transistor. Right now I'm just using the sample of the transistor. The rating depends upon the load. If your like motor is very heavy, then you may use a transistor suitable for it. Like motor requires 10 ampere, then you use a transistor which can provide 10 ampere. That is all you need for the rating. So for the NPN transistor, just delete the S2 relay. I replace this with a transistor like this. Connect the wire over here again. Now again for the last one, copy this NPN, and we need another NPN over here to replace the switch S4 like this. I also mirror this one to make it look presentable like this. I move it here like this. Now I connect this up like this, and I connect this over here like this. Now see the difference. We have replaced the relays with the transistors. Okay, I delete this, causing confusion. Now see, this is our new H bridge using transistors. Now this H bridge have both capabilities. The first H bridge using the switches or the relay only can control the direction, while this one will also allow us to control the speed as well. How? Because now this over here is our pin, the base pin of the transistor. The base pin of the transistor or the gate pin in case of a MOSFET, this is for the BJT, the base pin, and for the MOSFET it will be the drain pin, goes to our microcontroller, and the microcontroller or any controller that we are using like PLC or Raspberry Pi, whatever you have, can generate the PWM frequency, and that frequency of 5 kilohertz, 10 kilohertz, whatever we give to the transistor will control the speed of a DC motor. So that's how we control the speed of a DC motor using the PWM at the base of the gate pin. Now let me show you how this circuit works. So first of all, we need additional, so we cannot have a microcontroller on multisim, so we will use another power source. Like I bring in a DC power source or something like this. This will be like, okay, change the symbol to this. Okay, 5 volt. A microcontroller will give 5 or 3.3 volt, whatever it is. So just connect the positive side here. So I do that using a switch. So there we use another SPST switch, like we are giving power from the microcontroller like this, and I connect it here. Okay, now remember one thing. For the PNP side, rotate this. Now for the PNP side, this transistor, PNP transistor, only triggers when a 0 is given through a microcontroller, a 0 or it is connected to the ground. Else it will not trigger, and the NPN only triggers when a 1 is given or a positive like this. So this will be like this. Now connect this negative side to the PNP one of the 5 volt, like we are giving, it is just like simulating the one. If we trigger this switch, it means that a 0 is given to the PNP transistor using a microcontroller. Now I will use another switch at the bottom for the NPN side like this. Connect it like this. So this is just a switch, so we can like control it as well. So like this, and also copy this and bring it to the other side. Bring all three to this side as well for these transistors as well, like this. Okay, power goes there, switches goes here and here. Okay, again same, the PNP side will get the negative because PNP transistor only triggers when it is connected to the negative, or when a 0 is sent from the microcontroller, or it is connected to the ground. And the NPN only triggers when the base pin gets the 5 volt or it is connected to the positive of the control circuit, like this. Like this. Now for the simulation purpose, I will also connect the negative side to the ground as well, else simulation causes problems. So for every simulator software you have to do this, like this. Now guys, this is our new circuit. Now see that I add the voltmeter over here, positive here, positive to this side and negative end to this side. So now first what we want is that we want, now right now see all the transistors are not triggering. I run the simulation, see no transistor is triggering, we don't get any voltage. Okay, negative is not connected. Okay, bring it like this. Okay, run the simulation, no voltage, it is just millivolt, it is some leakage current or voltage coming from the transistor because we have not used resistors. Now take a look here. What is happening here is that we are not getting any transistor, is no transistor is right now, no base is connected. See, it is open, all the switches, like we have not sent any value from the microcontroller, all are open. So because this is the ground, PNP transistor only triggers when we get either a 0 from the microcontroller or the gate or a base pin is connected to the ground. In case of MOSFET, it will be the gate, and in case of BJT, it will be the base pin. So if it is connected to the ground, this transistor will get triggered. So this transistor once get triggered, it is connected to the positive side of the circuit, the same as done with the switches. Once it gets triggered, this path opens, this part gets closed, and we will get the positive at this end. So right now we want to bring positive here like this and negative over here to make the motor move in one direction. So I close this switch like this. I have closed this switch. Now it got the negative from the microcontroller, or we have given 0 to the PNP transistor. So now it's triggered. So now positive is at this end. But still the motor will not work. We didn't got 24 volt. Why? Because the negative side is open. No negative side is closed. Now this is the negative side. Now this is an NPN transistor. It only operates whenever a 5 volt positive signal like 3.3 or 5 volt or a 1 from the microcontroller is given to its base or gate pin in case of a MOSFET. So in case of BJT, it will be base, and in case of MOSFET, it will be the gate pin. So we close this. See, now we get the negative over here as well, because now once we close the switch, this path gets closed and we get negative here. See, we got the 23.964, that is 24 volt here. So now the motor is moving in one direction. Now I open both the switches like this. Now again, motor is no longer working. Now I close this switch and this switch. Now see, again the motor is working, but this time it's negative. So this has inverted. Now this side is negative and this side is positive. Why? Because this side is closed. So this transistor got, like, it switch got closed. We got the positive here from above, and then we close this switch. So it got the negative from here to here. So in this way, now the motor is in the opposite direction. Again, I do the same. I open these switches and I close this switch. Okay, let's open this. Now I close S1 and S4. Okay, S1 and S4. Now motor is in positive direction. Now we open S1 and S4. I close S2 and S3. Now it's minus 23. Now again I do the same. Now it's 23. Now guys, this is how you control the direction using the transition. Now to control the speed, you will replace these with the PWM. Like in case of a microcontroller, you will be having a PWM pin here, one PWM wire here, and one PWM wire here to enable the gates. So that PWM wire will allow us to control the speed of the DC motor. So instead of giving only the signal of like 0 or 5 volt like we are doing here, we will not be giving this. We will be giving a PWM pulse, and that will decide how much voltage the transistor will allow to pass. So this is how you control the speed and direction of a DC motor using the H bridge. So guys, I hope you guys learned something from this video. If you have any questions, you may ask. So we'll see you in the next lecture.